Now, yes. Okay.
Okay. Now, the point of this poster is that we analyze from long slit, high dispersion spectroscopic data, we analyze the behavior of emission lines, of different emission lines, to try to ascertain whether there are differences in the recombination lines and the forbidden lines of the same ion because of this problem of the difference in abundance determinations. And we found that, for example, in the oxygen 3 permitted line, oxygen 2 permitted line, which should be coexistent with the 507 line, there's a significant difference in where does the position velocity position velocity diagram, there's a significant difference in where is the emission coming from. So that is pointing out to a different region where they are being emitted. There's they come from the same region, but in addition, another region.
Thank you.
I have already concluded.
Okay, this is an exploratory study to see if current evolutionary models and models for stellar wind parameters are capable of producing the structures and the X-rays and ionization you see in the born-again planetary nebula phase. So we take some current stellar evolution models, and on the basis of the times, the luminosities, masses, and effective temperatures from those tracks, we use theoretical models of the mass loss rate in the different stages to then feed in as inputs to radiation hydrodynamics model. And from that we see that in 1D you get something very boring that doesn't really tell you anything, and in 2D you get the formation of various structures due to different sorts of instabilities, hydrodynamical, cooling, and shadowing instability and ionization. We also take into account the abundance changes in the planetary nebula.
Okay, thank you very much for just
So we observed chemical abundances in planetary nebulae at M31 whose locations begin at the outer end of the spiral arms at 20 kiloparsecs and go all the way out to 60 kiloparsecs. What we found was that the oxygen abundances are solar. There is no measurable gradient at all between 20 and 60 kiloparsecs. We attribute this to a recent starburst from metal-rich material that was released in a collision between M31 and M33 about 3 gigayears ago.
Alright. A couple of years ago, we found a boson in the jet-like feature in the very outer edge, 40 minutes away from the central tower of the helix. So we took some images in the spectra, high-resolution spectra, in order to try to identify their origin. And we found the result of this work was that the boson feature, which was in the northeast of the helix, was made by the movement of the helix itself as it flows in the ISM, while the jet in the southwest has a jet-like origin, and because it has very high velocities and very strong influence. Okay. And the second one, there's another poster. Okay, that's another planetary nebula, KJBN8. It's a polypolar planetary nebula with 3 different direction bipolar structures. And what we've done here, we took high-resolution images of different lobes of these structures, and we measured the expansion proper motion from a post plate from 1954 and the image that we took in 2011, and we recalculate the distance of this planetary nebula to 18 kiloparsec. And another interesting result in this planetary nebula is that we found that it might have an analog origin. And I think you can have a look for more information.
Dr. Raposo, okay, thank you very much. Okay, so now
well, these are our observations of low mass nebulae. I have already presented them in my talk. So if you want to see all the details on the interpretation and some spectra and some of the results, go to poster A7, and also you will find the corresponding reference to look at the paper, which is of the same basis. So that I think also
thank you very much.
Hello everyone. I would like to invite you to discuss the 3D modeling of the NGC 2346. This is a bipolar nebula that has a binary system with eccentric star. We are using focusing code to run the models, and today I brought the results by using a atmospheric model and a black body as ionizing source. And up to now we didn't find any difference between the models. Thank you.
Thank you very much.
Hi guys, I'm most important before the parts. The first is infrared treatment. You can see here the side left, we have the outer, it's like an outer glass of by CNAB, and in the KS strand, H2, and also HSE, N2. And just beside those we have the linear stretches and a higher contrast. And just underneath that we have infrared spectroscopic data, which are shown here in the two boxes which we can see, which are represented up here in the top right corner. And in an image just right in that is the relative contributions of the mission components. And you probably can't really see there, but the green is the background, the red is in H2, and underneath that is a continuum. And then thirdly we have morphoclimatic modeling of the nebula, and which is actually used shape, and down here at the bottom, in the middle, you can actually see my model that I generated as a shape, and this beside is a grayscale image for comparison. And just underneath that, we have 3 PV arrays, which are taken for a long slit directly down the major axis of the nebula.
My work is the detection of new planetary nebula with light path. We realize a study between 20 and 21 Earth in realization and of the INT IPAS survey. Our study is dedicated to humble the missing planetary nebula, particularly in zone of heavy extinction where a large part of thin and more volatile to be hidden. At this moment, we found 66 new planetary nebula candidates, and of which 4 spectroscopically identifies as the planetary nebula 2 are present in the poster image. Thank you.
In this poster, this morning, one of the speakers described how IFU spectrographs work. In this poster, we show how these instruments can provide tools, constraints for modeling. We can see angular distributions of densities, ionization degree, fluxes in different lines. IFU spectrographs could be used more extensively from deriving constraints to model planetary nebula. Basically, it's part of this course, it's course 12. Yeah.
Thank you.
So Kepler has been staring at 14 by 48 square degrees of sky for a while. In that field, there are 6 planetary nebulae, 6 thanks to the help of the deep sky hunters from whom we heard this morning. We were looking for binaries because Kepler can look at variability with exquisite resolution and detect binaries with low amplitudes. Out of the 6 objects, we found 2 that I would say are definitive binaries, one with a radial velocity follow-up. 2 objects in the middle, the round ones, are flatliners. There's really no variability we can find down to very good precision. The last two, the one to the left, the last two, one is variable, but it's kind of irregular, and it's likely a variability due to rotation. The rotation is being found to be about 50 kilometers per second, which is really fast for a central star, probably is a past merger. And the last object is Kernberger 61, discovered by Matthias Kernberger. And that object has a variability every six days that seems to be some kind of cataclysmic variability.
In this poster, I present an analysis of ionization correction factors for planetary nebulae. Using clouding, we have computed a large grid of models covering a wide range of physical parameters, and we derive a set of recipes to calculate the contribution of unobserved ions to total abundances. And what is more important is that we also provide analytical expressions to estimate the errors associated to these ionization correction factors.
So Katrina Exter is not doing very well today, so I'm going to be her for the poster presentation, and I need to sound like I know what I'm talking about. So this poster is about VD83 Mon, and so it's a very peculiar star that went through a very important outburst, and so it went through an increase of luminosity of 100 and an extreme change of spectral type from K to an M star, full star, to an L supergiant star, and all that within 3 months. So that was documented by HST data, and also there are also mid-infrared data. And so Katrina complements the observations with far-infrared data from Herschel with imaging and spectroscopy, where she traces the cold, newly formed dust, and also detecting some emission bands. So she gives some estimates of the dust mass in the far infrared, and also shows some line detections like CO and para and ortho-water lines.
Thank you very much.
It's me again. It's also postered by Katrina. Yeah, so this one I know. This is a poster about the spectroscopy data part of the Hercules Planetary Nebula Survey. So it's a survey that uses Herschel data in the far infrared using imaging and spectroscopy to study a sample of 11 planetary nebula. This poster concerns only the treatment of the spectroscopy data. So Katrina is PAX calibration scientist, and she knows quite a lot about that. And so our data are very peculiar because we use single pointings to study basically cover extended emission. And so they are quite tricky to calibrate, and also like there are things like telescope background subtraction, and also like flux calibration that are very complicated. And so you have many different ways to do calibration. And so all that is presented in this poster. If you're interested, you can have a look at it.
Thank you. Guilt is a very powerful emotion, and that is to be a friend. I was just a delivery boy, but I couldn't even do that right, and I left the posting behind in the Paris hotel. But Christophe finally printed it out, so it's up. So I'll just say a few words about this poster from Agnes. She's been working with a group of French amateurs. Principal among them is a person called Riviera, and he has been discovering, just like Deep Sky Hunters group, a number of interesting planetary nebulae. But amongst the nebulae, he did find an object that probably isn't planetary, called Utus 4, which sits in a sort of young environment in a cluster with probably a massive star at its core, but with a very highly collimated bipolar outflow, very reminiscent of the PNKGP8, which the posting heard about earlier. And so this is ongoing work from her and the French collaborators, which are on, like the Deep Sky Hunter group, are finding large numbers of, well, significant numbers of previously unknown planetaries in extant wide field databases. Thank you.
Thank you very much. We start more